Your
Your
second
second
topic
topic
is
is
this
this
Anova.
Anova.
So
So
Anova is
Anova
very
is
much
very much
interesting.
interesting.
When
When
you are
you are
trying to
trying
do
to do
any
any
kind
kind
of, you
of,
can
you
say,
can
the
say, the
psychological
psychological
research,
research,
or maybe there
maybe
are a
there are
lot
a
of
lot of
research
research
humanities
humanities
guys
guys
do.
do.
So
So
Anova
Anova
is
is
one of
one of
the,
the,
you
you
can
can
say,
say,
the
the
primary
primary
research
research
to check the causal effect, the cause and effect of any event. So that is called ANOVA. That is analysis of variance. Okay. So variance, I think in the last, in the regression part, I think ma'am had taught you this variance. So variance and a standard deviation are the two, you can say, the important factors which are very much important. Okay. But there is in machine learning, or you can say designing any, if you're designing any machine learning algorithm, so you come across the mean and variance many a times. Okay, mean and variance are, you can say, the most important or critical part in designing any ML algorithm. But here we will talk of this variance. Okay? So analysis of variance, ANOVA. So I'll try to cover this. Already I have covered correlation, causation. Now it's time to cover this ANOVA, one way, two way ANOVA, and there is some R programming, but I'll touch upon this Python, using Python. Okay, and how this ANOVA is applied in real world. Okay? How if you have to work on any business problem, then how we try to use this ANOVA. Okay, so this one we will see. So now, just coming to this one, correlation and causation, just to sum it up, there is a third factor here. Just see the traffic jam that was creating a bad mood, and so it was translating into tiredness. But if you see, this traffic jam is missing here. If someone sees you in bad mood and tiredness, they will feel that due to bad mood you are tired, but nobody knows it was a bad day for you, that you were in traffic jam for, let's say, 5-10 hours. Okay, so this the intervention of this third variable is very much important to check the causation part. Okay, which people lack. That is why people say that, correlation is causation, because they don't see the hidden part, the latent variable, the missing variable, the missing one, right? This one is the latent variable, means something which cannot measure, you cannot measure it, directly, is latent variable. For example, how happy you are, how sad you are the latent variable. I can't say you are, let's say, on this, let's say you are, let's say, how happy means you are 100. If I say 100 times you are happy, right? That can't be said that, and can't be quantified it. That is why in research, they give you a lot of questions to measure your happiness. And then they, based on those numerical value, they try to check in quantitative terms. They quantify you on the scale of 10, that how happy you are. Let's say you are 7. Let's say out of 10 you are 7, right? You are happy. So the latent variable, you cannot measure it directly, is the latent variable. So here traffic jam is also something like that. It's an intervention, a third variable, which is causing bad mood and translating into tiredness. Okay. So correlate, that is why I always say correlation does not equal to causation. Okay. So variance, if you see this variance part, hope this screen is visible. So variance part, what is variance? If I say, I think you people are having the maths background, so you might be knowing. So variance and standard deviation are the two such, you can say, maths. You can say in the stats, you typically understand this variance and standard deviation. Okay, so variance means the variability from the average mean. So let's say the mean marks of your batch is, let's say, 70, and someone has scored, let's say, 50, and someone has scored 80, 90, maybe 100 as well. So how your marks are spread, the measure of a spread, you can see, is variance from the mean value. Okay, so this will give you some kind of a bell-shaped curve, That is typically we call standard normal distribution, but we call it a normal distribution here because in a standard normal distribution, your mean is 0 and a standard deviation is 1. Okay. So variance means how spread your data is, how your data is, how far your data is from the mean value. Okay. So this one is a mathematical calculations if you have to check the variance. Okay. So let's say 1, 2, 2, 3, 4, 5, how your data is, varied from the mean value. So this is a variance. So in analysis of variance, we try to check the variance value between the two such, factors. So how they are varied from the mean value. Okay. So when you see this, analysis of variance, there are many, but I'm just trying to cover this one way and two way so that you can understand it properly. So a one way ANOVA, first let me try to define it, analysis of variance. So it's a collection of statistical models and their associated estimation procedures used to analyze the differences among the means. Okay? So ANOVA, we try to check the intervention of third variable on your target variable, maybe the response variable. I'll give you the example, so don't worry. So that we check how their variants are different. Okay? So this is your typical ANOVA. ANOVA are one way or two way. Okay? One way ANOVA and two way ANOVA, and there is also called MANCOVA, many way, right? But I am trying to cover this one way and two way. So just understand this one. If you understand one way ANOVA, you can easily understand two way ANOVA. Okay. So one way ANOVA. One way ANOVA is used to determine how one factor impacts a response variable. Okay. So I have given you one small example. Let's say your marks and the number of hours you devoted, right? So one factor impact a response variable. So here response variable would be your marks, how much marks you obtained. But one of the factor would be your studying techniques, how you are studying. Maybe you are studying in a group. Maybe you are studying through let's say, maybe you are watching a YouTube videos, or maybe you are doing self-study. Let's say there are three different factors. Let's say in a group of 100 students, I picked up 25, 25, 25, okay? And I have exposed to 4 different studying techniques. And then they were exposed to the final examination and I have captured their marks. So marks would be your response variable and your studying technique would be the factors. Okay? And then I'll check whether there is some kind of, you can say, causation or not, the causal effect of different studying techniques. Okay, so this is one way ANOVA where you have you can say different techniques, and then we try to check the impact of those on your response variable. Okay, so if you see this figure, factors is studying technique and response variable is your exam score. So if you are doing some let's say online study, offline in a group study or something like that, and then I'll check the exam score and I'll see if there is some kind of correlation or not. So I'll apply this ANOVA. I will apply ANOVA to check which technique is good. So someone who studied watching YouTube videos, maybe possibly they have a good you can say this score. So I'll say that you should use this this YouTube because the people have scored well. Okay, so ANOVA will try to check the impact of the variables. Okay, so ANOVA when you design ANOVA, so typically when we use ANOVA, so to compare several means with each other. Okay, so in that case we will try to use this ANOVA. I'll give you the clue that when you will apply ANOVA, so don't get confused with this visual. Okay, so if you have two groups, Okay, if you have two groups, then you apply this Anova. But if you have one sample, I think you have lecture, I think tomorrow in hypothesis testing. So where you will expose to this all these things, T test, Z test, and all. But here, just understand, if you have two groups means, let's say, studying techniques. Okay, let's say two techniques. Let's say online and offline. Okay, and then you are measuring the response. So if you have two groups, okay, if you have two groups, then you try to check this ANOVA. Okay, and then you have some kind of a hypothesis. I'll teach you here that how you formulate hypothesis as well, because once you formulate your hypothesis, if you have a data, then you formulate hypothesis, and then you keep on doing this ANOVA and all, right? So just see this part. This one is quite interesting one, and this will help you understand this, where you can apply ANOVA regression and logistic regression. This will give you a clue here, right? So if your dependent variable is continuous and your independent variable is categorical, then you will apply ANOVA. So can anybody tell me what is categorical variable? What are the categorical variables? Can anybody answer it? What is categorical variable? Am I audible?
So categorical data or variable basically is something in which we have to categorize something into different ways. For example, if we're categorizing gender into male, female, or something as good, bad.
Okay, good. So I mean, if it is male, female, let's say, if you are purchasing something or not purchase or no purchase, that could be the categorical one. Let's say if in case of a banking industry, if you are provided a loan, let's say rejection of a loan or acceptance of a loan, the binary one, okay, that could be the categorical one. Or in normal male, female, right? This kind of a stuff could be the categorical one. When you try to categorize it, right? That is a categorical variable. Okay. So just remember that this one, when you see any data set, I'm just giving you a clue. This will help you out in your coming sessions. That when you can apply regression, when you can apply logistic regression, okay, and where you can apply ANOVA, right? By looking only at the data set. If your response variable is continuous and your independent variable is categorical, then you will straight apply ANOVA. Okay. And in regression, I think you applied in the last class where your both dependent was continuous. Okay. So in that continuous means, let's say the salary of salary of an employee, that is continuous one. Maybe the age is continuous one. Okay. So these are the example of continuous one. So continuous means, I mean, the value are in the continuous format, but in categorical, you are very much specifying it in some categories. You are putting some labels, okay, class labels. Then that is a categorical one. Okay. But my intention is here only ANOVA. So dependent one continuous, and your independent variable should be categorical. Okay. So now. Okay, this one. If you see this one, the logistic regression, I'm just showing the data set just so that you can understand what is categorical and what is continuous one. Okay. If you see this data set, which I have used, I think this could be used for logistic regression. I'm not explaining what is logistic regression here, but this is a typical data set in Excel where it is written independent variable and dependent variable. Just look the two part only. So independent variable, let's say 6-7 variables are independent one, and dependent variable is, let's say you have a churn part. The churn is dependent. Churn means whether, let's say if this is a case, of one, you can say of a company where tenure of a employee age, address, income, ED, employee ID, equip ID, caller, something, something. These all are independent variable. And based on that, we have a historical data and we are seeing that, let's say employee number 1 is going to churn, employee number 2 is not gonna churn, employee number 3 is gonna churn, 4 we don't know, okay? Because these are the historical data, okay? So based on those, 0 to 3 is historical data and fourth one is now a test case. One of the employee who has lesser tenure of 7 years is 35 and this on. So this is data with the company. Now the company wants to know that this employee is gonna churn, means they're gonna leave this company or not. Okay, this is kind of a forecasting, you can say prediction. So this dependent variable here is your categorical, because yes and no, there are two labels. Churn is a class and that has a two labels, that is yes and no. Yes means you can put 1 when you encode it, and no could be the 0. Okay, so this one I'm just showing it how you see typically in Excel sheet. By looking at the Excel sheet, how you can at least figure out that what kind of ML algorithm, by looking at the numerical data set, how we can apply different algorithms by looking only at the data set. If you see this kind of a data set, at least you can say I can apply logistic regression, because this is a case of, because dependent variable is your categorical and independent one is continuous. But there is a reverse case here. In Anova, there is a reverse case. Okay. So let's say in one-way Anova, this is one of the example. Okay, one-way Anova. If I given you in the Excel sheet technique 1, technique 2, and technique 3, this is the study technique. Let's say online, offline, and maybe you have studied using YouTube, watching YouTube videos. Okay, there are 3 techniques, and 85, 86, these all are the marks typically. If you were exposed to technique 1, your let's say the out of 10, 12 students, your marks was 85, 86, 88 something. When you were exposed to technique 2, your marks are 91, 92 or something like that. Okay. So similarly with the technique 3. Okay. So if you see the response variable is continuous one. Response means this one. These entire marks is the response one. Okay. These are the marks obtained. So this, if you see, these are the continuous numbers. But if you see this one, technique 1, technique 2, and technique 3, these are the categorical value, okay, categorical variable. So technique 1, technique 2, technique 3 is independent variable. Your marks obtained is dependent variable. So this is a classical case of Anova. You will try to see is there is significant impact of having these techniques when you applied it, the marks increased or decreased, something, there is some significant difference or not. Because by looking at the marks, you can't say that technique 1 was good, technique 2 was good, or technique 3 was good. You can't say that. For that, you will first see the Anova part. If there is some significant difference by looking at the p values, then you can straightly come out and say, okay, technique 1 was good because it was giving the good result, right? By looking at the p value. I'll show you what is the p value now. Okay. So this is one more case. I'm showing you the case first so that you can have an idea that where you can apply at least Anova. Okay, I'm just showing you the data set first. And the example, obviously. Let's say an environmentalist wanted to determine if the mean acidity of rain differed among Alaska, Florida, and Texas. He randomly selected 6 rain dates. At each site obtained the following data. Okay, so this is the acidity. They try to check the rain in acidity, how much acid carries that rain. Okay, so they have selected Alaska, Florida, and Texas, and out of those they have selected 6 rain dates, and they have checked the acidity in that rain. So those acidity in the rain are significantly different or same. You just try to conclude this one. So obviously these all are your continuous variable, and Alaska, Florida, and Texas, this is the categorical variable, 3 category. So this is a case of Anova. Okay. Similarly, Anova could be modeled using this one, productivity and music, weight, let's say weight and group. So this could be the case of some of the data set. By looking at the data set, at least you can say we can apply Anova here. Okay. So now coming to this two-way Anova. Okay, two-way Anova means, there are 2 factors at least. and we have to try to check the impact of those two factors on response variable. Okay, so let's say if someone is interested in weight loss, so obviously when you go to gym and all, so they will give you some kind of, they will expose to some kind of exercise, and also they check whether you are male or female. Okay, based on those two factors, we'll try to check what kind of, let's say if that is a gym owner, so he'll try to check what kind of exercise I must provide to this. Maybe if she is a male, sorry, if they are male or female, what kind of exercise I should give them, so that it can help in the weight loss. So they will try to check the impact of level of exercise and gender on weight loss. So two-way ANOVA is used to determine how two factors impact a response variable and determine whether or not there is an interaction between the two factors. So I'll show you if I merge these two factors and then I try to check the weight loss. If level of exercise is, let's say XYG, and gender is male, so what kind, whether there is some significant weight loss or not. So in 2B ANOVA, just understand that there will be two factors and their impact on response variable we will check using 2-way ANOVA. Okay, this is a simple one. Okay, so there are some the data set. I'm just showing you previously, I mean the data set here first, so that you can understand how 2-way ANOVA data set looks like. Okay, so just see the kind of exercise plan. Let's say you were exposed to exercise plan A, B, and C. Okay, and the diet plan they have given you is 1, 2, and 3. 3 diet plan and 3 exercise. And then they checked you the weight loss. Okay, first, let's say 6 months, they have given you diet 1, and you were exposed to exercise plan, let's say A. And then they saw your weight loss was 10.2 kg. Then they exposed you to diet plan 2 and exercise plan B. Your weight loss was 10.4 kg. Similarly, diet plan 3, you were exposed to diet plan 3 and exercise plan given was C. Your weight loss is 8.4. So now they want to check. So, I mean, whether there is some significant difference or not. Even if I'm giving the, why not I just continue with diet plan 1 and exercise plan 1A? Why not? Why should I use these 2 and 3? Just they try to check there is some significant difference or not. So there is a 2-way ANOVA, means one factor is diet plan and other factor is exercise plan. Both are categorical, but your response variable is continuous one. Just see this one. This is a clue. Okay, whenever you design any ANOVA model, just see the response variable and their independent variable. Okay? This diet plan and exercise plan independent one, and your weight loss, it's in a grid format. This is your continuous one. Similarly, the fertilizer you use, let's say for a land A, B, and C, the 4 fertilizer you have used, and you have, let's say, 4 pieces of land. Okay, and you try to check their impact on the yield. This one is yield, 15, 18, 16, 15. These are the yields. When you were exposed to fertilizer A, B, C, D, and land 1, 2, 3, 4, 5. Is there any significant difference in yield or not? If not, then we will continue with any one plan. If there is a significant difference, then further study is required. Then which plan is good? Which fertilizer and which combination of which land and which combination of fertilizer is good? Okay. So this is a clue when you design any ANOVA. Okay. So if there is a case of, let's say, 1-way ANOVA, diet plan 1, diet 2, diet 3. Okay. So the category is independent variable is diet 1, diet 2, diet 3, and this one is, let's say, weight loss maybe. Okay. See, 1-way ANOVA. In 2-way ANOVA, there is a 2 factors, diet 1, diet 2, diet 3. Okay. And male and female. There are 2 categories. Okay. So one factor is diet, other factor is gender. So 2 independent factor and response variable is this one. Weight loss. This is not comma. This is 1.2. Let's say 1.2 kg. You have reduced 1.3, 1.6. So your response variable is continuous, but your independent variable is categorical. Okay. So similarly, when you design any, Anova, there is a within the variance and between the variance. Okay. So this is a kind of a mathematical stuff. But just remember that in Anova, within variance and between variance is very much important, and the ratio will give you the F score. F score is nothing but it's Anova typically. Okay. So this is a maths. So don't go in deeper into this maths. When I'll explain you using Python programming, then you will understand this one. Okay. So F test is nothing but it's Anova. Let's say if there are two groups. So we'll try to check how much there is a within the variance and between the variance. Let's say diet plan and exercise. So how much there is a variance, and if you check their ratio between and within, this will give you the app score. Okay. So just see how you can implement this one app score. Okay. So just see what is the level of significance here. Okay. I think you might be knowing when you design any hypothesis testing, we struggle with critical 5% level of significance, maybe 10% sometime, and we mostly get confused with this visual. So if you see this one, this visual, this one is a typical bell-shaped curve where this is acceptance region and this one is a critical region, 2.5%, 2.5%, because we have to check the 5% of level of significance. So level of significance means, let's say if you are doing 100 times a single experiment, may possible that you get failed 5 times. Okay, so that is a level of significance. Okay, so in Anova or any hypothesis testing, when you build ML model, you have to take help of this level of significance, and that could be handled using p-values. If your p-value is less than 0.05, then I mean that is significant one. It means somehow your data points are not falling in critical region where you will reject the null hypothesis. So I think it will be more clear when you expose to this hypothesis testing. But here just understand level of significance in a layman terms. If you do 100 times a single experiment, you may fail 5 times. Okay, there is a 5% risk associated with that experiment. Okay. So, and if your value, let's say unseen value fall here, then you accept your null hypothesis. Otherwise, you reject it. Okay. I'll show you, so don't worry. So in Python programming, okay. So in Anova, let me do one thing. Let me just pull out my Python. Is my screen visible? Can you confirm? Is my screen visible? Yeah, speak a little louder so that I can answer. Okay, so this is one case. Hope if my screen is visible, then you can easily see. It's a blurred one, but I'm just reading it out. A company manager wants to compare sales of 3 different salesmen. Just understand this. Sales of 3 different salesmen. The manager collected the data of sales of salesmen A, B, and C measured in 1,000, a period of 6 months as shown in the below. And we have to check 5%, and they have collected 5% level of significance. Okay. So now we have to apply one-way Anova. Okay, why we are applying one-way Anova? Let's say salesman, there is a 3 salesmen. So 3 category of salesmen. It's an independent variable first, because you have to fit in the Anova, one-way Anova. So independent variable should be categorical. We have 3 different salesmen, 3 category of salesmen. That is why it's independent variable. But the sales data, how much they sold, 21, 15, A. Salesman A, how much they sold? 17, 20. So this is the sales data. Sales is, this one is a continuous one. So now I'm able to model it in a Anova format, because my independent variable, the salesmen are categorical, one A, B, and C. There are three one, and their sales are continuous. So now I'm able to fit in the Anova one-way Anova model. Okay. So here, when you apply this hypothesis testing, you assume some hypothesis. Obviously, when you design any Anova, so first you take this hypothesis, some assumptions you can say. So we are saying H naught means null hypothesis. We are saying the mean sales are equal. We are saying the mean sales of A, B, C salesmen are equal. I mean, they are not, they are selling on the same pace. We are saying that is H naught. But alternate hypothesis is we are saying no, there is some significant difference. We are assuming that may be possible that salesmen B and C are selling more. Okay, so that is your alternate hypothesis. Okay, so mu1, mu2, and mu3, that is the mean value we can say. So H naught means mean sales of A, B, and C is same. Now we are converting into mathematical format, and we are saying no, the mean sales are unequal. I mean, they are selling at a different pace. Okay. So now how we are going to apply Anova here? Okay, I'm just using a Python. So in Python programming, I'm just using Jupyter Notebook. Hope you can apply using Colab, Google Colab as well. So one-way Anova. Yeah, one-way Anova, just see. One-way Anova. Data set, you all people have seen it. So in one-way Anova, in Python, percentage matplotlib inline, import panda as PD. These are the libraries, I think you people know it. My stats model import API SM, okay, and OLS is ordinary least square. Okay. So this is a linear model, Anova. Similarly, your linear regression is a linear model. That is why OLS command is, OLS word is here. Okay, import OLS. Okay. So stats, these are some libraries. So when you run it, you get some asterisk sign because it's still running it. Okay. How many of you know Python programming? You know Python? You all people know Python programming or what? Am I audible? How many of you know Python programming? No one. Okay, so this is data set. Okay, so data set you'll see already data I have shown you the product and sales. Okay, and then you run this command new OLS. This is one-way Anova. OLS is ordinary least square. Your sales is response variable and product is your independent variable. And we are fetching data from a data and we are fitting this model. That is why fit function is there. And when you run this Anova LM is linear model here. Okay. A statistical model, and Anova LM is a function that is a linear model. And we are passing this new means here, data here, this model we are passing to here. And you will get this kind of, table. So if you see this one, this value, only this value, this is less than, I think 0.05. No, this is not less than 0.05. Okay. So you are not gonna reject the null hypothesis. Just see. If the value is less than 0.05, then only you will reject a null hypothesis. Otherwise, you will not reject the null hypothesis. Okay. So here the value is not less than 0.05. So we will accept the, we will not reject the null hypothesis. We will go for alternate hypothesis means the mean sales of those three salesmen are same or different. Okay, it's not same, it's a different. Okay, so p value will give you this kind of a p. Okay? So this is one way ANOVA, and for the case of a two-way ANOVA, let me show you how we can model two-way ANOVA. 1 minute. So two-way ANOVA. Yeah, for two-way ANOVA, the same command you're gonna run it. It's a similar command, but there is one change in this one. OLS we have to fit in the same, but there is change here. In two-way ANOVA, let's say this one is dependent variable cured. Let's say, okay, 1 minute, let me show you the data first. Where is, yeah. For two-way ANOVA, there is one more case here. Yeah, okay. So in two-way ANOVA, there is one case, an experiment is carried out to test whether three different types of drug, A, B, C, have different effect on males and female. A sample consists of 15 males and 15 females were selected, and the cure percentage after using the drug was recorded as follows. Okay. So A, B, and C are the three drugs. Male, female, let's say the gender is one factor and drug is one factor. There are two independent factor. One is drug, other one is gender. And we are trying to check this one, different drug and their how much cure percentage. Okay. So 55%, 90%, these are your dependent variable. So two-way ANOVA, there are two factors. One is gender, other is drug and their effect, whether it is significant or not. When you model it, so you assume alternate and null hypothesis, null and alternate hypothesis. So we say there is no difference between effect of drug on the cure percentage. In null, obviously, we take the basic assumptions. We try to see there is no effect of anything in null hypothesis. Typically, we take those assumptions. The gender has no effect on cure percentage, and also we are seeing there is if you include this gender and some drug, also there is no effect. In alternate, obviously reverse of that. We are seeing that there is a difference between the effect of drug. There is a effect of gender also on cure percentage. If it is male, they have a higher percentage of cure, maybe possibility. There is an interaction between the gender and drug. If you are selecting a particular gender and particular drug, they have a higher percentage of cured. So this could be your alternate hypothesis. So how you are going to model it? You have seen the data here. So in Python, how you're going to model it? So in a two-way ANOVA, if you see this one, where is a two-way ANOVA? If you see two-way ANOVA, cured is your dependent one and drug and gender is your independent variable. Okay, drug and gender. There are two independent variables. Okay. So when you run it, and EN is ANOVA, you're trying to model it. The same command, you're going to use it. A similar command, but there is a change here only. Tilde sign is showing your relationship. Okay. Relationship with the cured and their effect on cured by your independent variable drug and gender, and this tilde sign is your relationship. Okay. So when you run this command, it's a simple one. So if you see this one, there is not a single value which is less than, you can say, 0.05. Okay. This one is a p value. This one is a p value. So not a single one is your less than 0.05. So we are not going to reject the null hypothesis. Okay. So it means there is no effect of all this stuff, the male, gender, and all these things. Okay. So this could be one of the way. But here, if you see this interaction one, Okay. So if you see this interaction means we are saying if I include a particular gender and drug, if I select a particular gender and particular drug, whether there is some significant effect on cure percentage or not. If you see this one, the last one, it's less than 0.05. It means it is significant. It means there is an effect of some drug on some particular gender. Okay. So this ANOVA is giving you some clue about the causal effect, the cause of drug and cause of some particular gender on cured. So if I give you the data set of cured and gender, it may be highly correlated, but there is a correlation or not that could be checked using this kind of a ANOVA analysis. Okay. So drug has some effect on cured. So the causal effect could be, modeled and could be verified using ANOVA. So this is what I was trying to establish, that causation is not, or you can say correlation is not always causation. Okay, so you can design one-way ANOVA and two-way ANOVA in this fashion. So this is how I'll share you this Python programming with you so that you can have a look how you can design one-way ANOVA and two-way ANOVA by simply running a simple command. Okay. So this is your one-way and two-way ANOVA. Any questions so far? Any questions so far? Are you people there or what? Are you people there or not?
Yes, sir.
Why you people don't speak? So it's like a monologue. I mean, sometimes I feel like I'm got disconnected. I'm speaking to a blackboard sometimes. So speak in between so that there is some kind of not should be the monologue here. Okay, so I'm just concluding this one. I'm just giving you some examples of ANOVA where you can apply it. Okay, so I will be sharing you all stuff, so don't worry. So just see where you can apply ANOVA. Oh, this screen is visible, right? Just confirm it once so that okay, is it visible, right?
Yes, sir.
Okay, fine. So ANOVA real life example, this one is quite interesting one. Let's say a large farm, let's say a large scale farm is interested in understanding which of the three different fertilizers lead to highest crop yield. This is a one-way ANOVA case or two-way ANOVA case. I mean, if you could figure out three different fertilizers and crop yield, we are trying to, check their effect.
It's a two-way ANOVA.
थोड़ा जोर से बोलो आप, वन वे और टू वे?
Sir, it's a two-way ANOVA.
Two-way ANOVA, okay. Why not one-way ANOVA? Why not one-way ANOVA?
So there are two factors, fertilizers and the feeds.
The crop yield is not a factor.
Fields, 10 different fields.
Only fertilizers.
They sprinkled each fertilizers on 10 different fields and measure the total yield. Okay, yes. Yeah, two-way ANOVA. You are right. 10 different fields. It's a categorical one. And 3 different fertilizers. And crop yield your response variable. Got it? So you are right. This is a two-way ANOVA case. Because two factors and their effect on crop yield. Okay? So okay, fine. So your answer was right. So this is a typical case of your two-way ANOVA. And and basically ANOVA was initially designed only for agricultural, purpose. And later on, people felt that this could be also applied in business, also enterprise. So they picked up this concept for the further the business analysis and all. So typically this ANOVA was designed only for the agriculture, right? So screen is not moving. Yeah, okay. So hope second screen is visible. Okay, this one. The second case, just see, just let me know if it is one way or two way ANOVA case. A grocery chain, let's say 7-Eleven, wants to know if 3 different types of advertisement affect mean sales differently. They use each type of advertisement at 10 different stores for 1 month and measure the total sales for each store at the end of the month. This is a one way or two way? One way or two way? Speak loudly little bit. Two way. So what are the independent variable here? The 2 independent variable, can anybody let me? What are the 2 independent variable?
Stores and advertisements.
Number of stores, okay, and
Three types of advertisements.
Good. Types of advertisement and the number of, and obviously the stores. So these are the 2, you can say the categorical variables. And what is response variable? Mean sales, right?
Sales.
Yeah, mean sales. Okay. Or in Anova, we typically capture this mean value. So mean sales is your response, right? So by looking only at, you can have a sense that where is one way and two way, right? So this will give you a clue, right? Because most of the organizations, they have to run this kind of ANOVA to check whether, what they want to change in their strategy, methodology. So that is why they take help of this ANOVA, because this will give you a larger clue. Okay? And this one, this one is a biologist wants to know how different level of sunlight exposure. There are 3 categories: no sunlight, low sunlight, and medium sunlight, and high sunlight. Okay, 4. And watering frequency, daily, weekly, impact the growth of certain plant. One way or two way? One way or two way? Two way. Two way, yeah. Because there are two independent factor. One is sunlight. They have 4 labels: no sunlight, low, medium, and high. And watering frequency is another, categorical variable, daily, weekly, and their impact. Obviously, the growth, how much it has grown in centimeter, let's say the mean growth. That is your response variable in continuous format. So that is a two-way number. Okay. So my aim was just to make it sure that by looking only at the data set, by looking at how they have written it, how you can formulate whether this is a case of one way or two way. Okay, so now I think people can understand easily that where you can apply one way, two way, and which is one way and two way classification problem, right? One way and two way designing problem. Okay, so this is, and also this is some examples, broad examples, because everywhere you can apply Anova, right? For example, in retail, let's say if you have a large retail store, and if they are interested in understanding whether different types of promotions, right, store layout, advertisement tactics, etc., lead to different sales. This is very much important, right? If you go in a mall, so they come up with different promotions strategy. Sometimes also they design your layout, their retail chain layout in such a way that their sales happens more. And also their advertisement techniques, whether they should go for a bigger billboards or they should focus on maybe the online marketing strategy, so that can lead to more sales. Okay, so they only keep on running this Anova test on all. So good. Okay, so this is the exact type of analysis that Anova is built for. Okay, for a medical industry, researchers are often interested in whether or not different medicines, medications affect patients differently, which is why they often use one way, two way. Obviously, they keep on checking whether which medicine is affecting, or which medicine is affecting a negative way or a positive way, whether there is some causal effect or not. So in medicine, you can say in the medical field, they also take help of this for environmental science. Obviously, you have seen different levels of, I have given the example of plants, and even in the wildlife, they also check, the different factors which influence some parameters in environmental science or not. Okay, So Anova is wide, you can say, you can say term that used for different analysis, and it's one of the wonderful, you can say, concept in machine learning, you can say, in stats, you can say, which can be applied in real life business, you can say. So it's very much important, right? So this is all from my side. Hope